So today we are going to talk about the constant rate of change in equations. To begin, let's first talk about the different parts to an equation. One of the most common types of equations is the slope-intercept form, which is the y equals mx plus b. M is the coefficient or the slope of the line. In other words, it's the constant rate of change. B is the y-intercept, or where the line crosses the y or vertical axis on the graph. So the y variable in this equation is the dependent variable, as its value depends on the value of x in the equation. So therefore, the x variable is the independent variable. So in this equation at the top right in red is an example of this type of equation. So y equals negative 2x plus 7. So the negative 2x is the slope, or the constant rate of change, and the plus 7 is the y-intercept. So on a graph, plus 7 is where the line crosses the y-axis, or the vertical axis. So what is the rate of change? The technical definition of the rate of change is how one quantity changes in relation to another. So this is also the slope of a line. So in an equation, you find this rate of change with the m value. For a table, you find the difference between two of the y values over the distance between two of the x values. And then on a graph, you just find the rise over run of 2 points on the graph, and that is your slope or rate of change. For today, we are going to focus on rate of change in equations. So for equations, we have the y equals mx plus b example. So in this type of equation, the m value is the constant rate of change or slope of the line. So I have it highlighted in the next line. So y equals 2x minus 5. The 2 is the constant rate of change. And so for this next equation, y equals negative 1/2 x plus 3, you can try and figure out what the rate of change is. And the rate of change is negative 1/2. And then here's another, y equals negative 6x plus 4. The rate of change is negative 6. So here we have another example that is unlike the y equals mx plus b. For this, you'll have to do some problem solving. So for this, I will go ahead and do the example. So we have y equals, in parentheses, x plus, or 2 parentheses x plus 7 and parentheses plus 8. So what we would have to do first is use the distributive property, and so we would do y equals 2x plus 14 plus 8. So what you do, you take the 2 parentheses x plus 7, so you take 2 times x equals 2x plus 2 times 7 equals positive 14 plus the 8. And then next, you add the commonalities. So y equals 2x plus 22 as positive 14 and positive 8, you add together to get 22. And the constant rate of change for this equation is 2. Then another example, we have y equals 4 in parentheses x plus 3 plus 2 parentheses x plus 2. First, use the distributive property again, so you get 4x plus 12 plus 2x plus 4. You add 4x plus 2x to get 6x, and you add the 12 and the 4 to get 16. So this equation ends up being y equals 6x plus 16, and the constant rate of change is 6 for this equation. So the slope is 6. So here's a story problem. So Jackie lives in New York City. She wants to go to Times Square but needs to figure out how much money she needs to bring with her to pay for the taxi. Taxi company charges a $5 fee no matter how far you ride, plus an extra 50 cents for every mile. Write an equation to help her figure out how much she will have to pay for her taxi ride. So for this question, we can use the y equals mx plus b form, and we need to figure out what all we need to add into this equation. So I look throughout the story problem and I see that no matter what, she is going to have to pay $5. Even if she gets in the car and gets dropped off 100 feet away, she still has to pay $5. So I'm going to put that in my equation. And then I also see in my equation that she has to pay 50 cents for every mile. So I also know I have to use 50 cents in my equation. Using the y equals mx plus b form, I know that the 50 cents is going to be the dependent variable because no matter, she has to figure out how much she'll have to pay depending on how many miles she rides. So let's say she rides 2 miles, then 0.5 times 2 is $1. So my equation will end up being y equals 0.5 x plus 5. So 5 would be the b value, since no matter what, she's paying $5. And then the 50 cents is the m value, since you use that number to find out the additional cost dependent on how many miles she rides. So no matter how many miles she'll ride within the city using this taxi company, she will use this equation. So let's say she does ride 2 miles to get to Times Square. 0.5 times 2 is 1 plus 5, so she'll end up paying $6. So that is basically all about the constant rate of change in equations. There are different ways to find rate of change depending on if you have equations, graphs, or tables like in before, but this is how you would find the rate of change if you were given an equation. And if you weren't given the typical y equals mx plus b form, how to use the distributive property and add up numbers and do a whole bunch of craziness in order to get your equation to look like the y equals mx plus b form to help you better find the constant rate of change.